Hi, this is Kevin Quan with Knight Composites here at the University of Toronto Institute for Aerospace Studies. I just wanted to show everybody our smaller 30 centimeter wind tunnel. Now, of course, it's not 30 centimeters long. This test section is 30 centimeters by 30 centimeters. And this is where we test all the airfoil sections for our Knight Composite aero wheels. So this is an example of the airfoil sections that we use to test in this tunnel. This is an example of the Knight 65 airfoil. This is the tire and this is the trailing edge. So what did we learn here at this tunnel? What we actually learned is that when the wind is coming from this direction hitting the tire, it almost immediately separates. In fact, almost all of the aerodynamic gains in an aero wheel is occurring when the airfoil is flipped the other way. That is the trailing edge. So when the air is coming this way, it actually goes across this perfect airfoil and then off the tire and then hopefully onto the front end of your bike. Now this is in contrast to our competitors. For instance, this is a Zip 404. Now they've designed it so that the trailing edge is fairly symmetrical with the tire. What that means is when it's flipped the other way, it actually separates earlier than what you normally would expect. That's because the leading edge is actually that much more blunt. Now contrast that to Bontrager. They do a symmetrical airfoil. That means they think that the air is doing the same, or even more importantly, when the air is coming this way than when coming this way. Our results are the exact opposite. So when you actually test against the Bontrager, you'll find that the Knight 65 will actually have a lot more lift, which means less drag at higher yaws.